What's up everybody, welcome back. It's time for part 2 in our turret series, and today we're going to take a look at setting up a bit of the behavior. So it's going to be a pretty simple behavior. The turret is going to have two states, idle and combat, and we're going to use a behavior tree and a blackboard to set things up. So normally I probably would not use a behavior tree for a simple setup like this, but because it's so simple, it's also easier to understand how everything works together. So probably in a normal situation a bit of an overkill, but for the sake of this tutorial it's actually a good thing. And later on in the series we're gonna do other AI that can actually move around and chase the player and things like that. So then we will get to a bit more complicated stuff as well. If you like this series, you can become a member of the channel or become a Patreon, and then you will get access to the premium channels in the Discord and also a download for the project file if you're interested in that. I will upload the files as soon as the series on YouTube is completed. Okay, so with all of that stuff out of the way, let's dive into today's video. So first of all, I want to make a small correction to the stuff we already did. So I already made a small mistake, and it's not really breaking anything, but it makes things a little bit more confusing. So I just want to make everything right. So it kind of happened because I didn't name my variables consistently, and I should have just sticked to the names in the animation blueprint, but I made up my own name. So that's not really smart. So we want to go into the GDR turret, and what we want to do, the isTarget inside boolean, we actually want to change that to isAiming, and the isAiming boolean, we want to change that to isShieldOpen. So that's what we're going to do first. Let's rename isAiming, so isShieldOpen. And then for isTarget inside, we're going to change that one to isAiming, like so. And now we want to go into our animation blueprint. So let's go to turrets, turret inhibitors, animations, and then that should be in here. So if we go to our blueprint, thread save, update animation. So over here, we have the setter for the aiming bool in the animation blueprint. And for this one, we want to make sure that we actually have our turret isAiming hooked up over here. So previously we had isTarget inside hooked up over here. And then we want to go to the right. And over here where we use the aiming boolean, we're going to get rid of this one. And we're going to drag off and again look for the property access. And we want to bind this one to the isShieldOpen bool, just like this. Compile it and save. So now everything matches up again and it's just a little bit less confusing. So with that out of the way, let's dive into the actual turret controller to set up the first part of the behavior. So let's go to our turret controller, and we added the perception component, and we're going to use the perception component to determine what our targets are. So if you remember, we added the stimuli source component to our character. So basically what we're going to do, every actor that we can perceive, we automatically make that a target. So we're not going to make any checks simply because we have the stimuli source component on the character. That will mean that's a target for the perception over here. So if we select our perception, we can scroll down and we can add the on-target perception updated event. So you want to use the second one in here because that also gives a reference to the actor that has been perceived. And then, like I mentioned, you will get a reference to the current actor and also a stimuli struct with the information about the perception. So what we want to do in here is make sure that we add all the actors that we perceive to an array of target actors. So we're going to add a variable, and that's going to be all target actors. And that's going to be an array of actors. So change it into an actor and turn it into an array. So basically we can have multiple targets, and we're simply going to pick one of those targets. So what we want to do for the perception updated we want to make sure that this is actually perceived by the site perception. So we're going to drag off the stimulus, and we want to get the sense class for stimulus. Then we can drag off that class and simply compare it. So do equal to, and we're going to look for the site sense. And then you have the config and the normal one. So you want to select normal, just site sense over here. So this will tell us this has actually been perceived by the site sense. Currently we only have the site sense, but we're going to add this in here for completion's sake anyway. So hook it up to a branch. And after that we can break our stimuli struct. So let's drag off here and break it. And if we look at the bottom, we have a boolean in here that says successfully sensed. So for our site perception, that basically means if this is true, we entered the site range, and if we were previously perceived and we left the site range, this will be false. So we're going to grab a branch, hook it up to the true pin, and plug it in here. So if this is true, a character walked into the site range, we're going to add that character to the target actors. So drag it in and simply add a unique entry. So this will make sure there's no duplicates in here. And for the actor, we can simply get it off the event. So plug it in over here. And if this is false, so if our actor left the site range, we want to remove it from the target array. And for that, I'm going to create a function because later we want to add some extra functionality in there. So let's create a new function, and we're going to call this remove target actor. And we're simply going to get our array of target actors and remove an item. So we can hook it up and pass on the actual actor. Let's make sure we change the name in here, so the target actor. And that's all for now. So as I mentioned, we're going to expand this later. So that's why I made this a function. So we can go back to the event graph and simply call that function over here, plug it into the false pin, and again make sure you hook up the actor that actually comes from the event over here. So this is all we're going to do for our site perception. And now we have an array of all of the actors that are inside of our site range. So let's compile and save that one, and let's continue. As I mentioned, our turret is going to have two states. It's going to be either idle or in combat. And we're going to add an enumeration for that so we can easily see what state the turret is in. And I want to add it inside of the behavior folder so we have it nicely organized. So first of all, I'm going to create a new folder in here and call this behavior. Open it up, and we're going to create a new enumeration. So go to blueprints and then enumeration. So this is going to be the enumeration for the turret state. Open it up, and we're simply going to add two enumerators in here. The first one is going to be idle, and the second one is going to be combat. And that's all. So save it and close it down. So now we can go back into our turret character and actually do some setup in here for the states of the turret. So the first thing I want to do is add all of these variables that we already have inside of a category for the animation blueprint. So as you remembered, all of these variables are actually only to drive our animation blueprint. So I'm simply going to select it over here and call the category AnimBP and move everything over. So you don't really need to do it, but let's just keep things organized for now. So with that in place, we need a few other variables in here. So first of all, let's take care of that. We want to add the current target. So let's create a new variable, current target, and that's going to be an actor. So as you might notice, I'm using an actor class for all of the target variables. So if we migrate this turret into another project later, we don't have to worry about the class of our character. It will simply target actors. So that should work in any project. So that's the current target. Then we also want the turret state. So let's add turret state, and that's the enumeration that we just created. So we want to change it into our enum turret state. And then we need the burst count. So I'm going to make the turret fire in bursts. So we need an integer so we can actually keep track of the amount of shots fired. So turn it into an integer called burst count. And then we need two more variables for the fx that we're going to use. So there's all kinds of fx included in the pack. So let's make sure that we actually use those. So let's create a new variable, and the first one is going to be the fx for the targeting beam. And we want to change it into a cascade particle component. So unfortunately they are not Niagara systems, but we're going to use them anyway. So we have the cascade particle system component. You want to select that one. And we need a second fx. So let's duplicate this one, and that's going to be the fx exposed. And again, that's a cascade particle system, so that's fine. So we have the variables that we want in place. And first of all, let's go to the event graph and let's start a bit of setup in here. Let's get rid of overlap and tick for now and only keep begin play. So we're going to use a Blackboard and a behavior tree, as I mentioned, and we're going to get to those a little bit later in this series, or actually in this episode. And what I want to do now is make sure that we have a reference stored to our Blackboard on our character. So if we right click and we can get our Blackboard. And I'm just going to store this in a variable so we don't have to get it every time. So let's drag off here, promote to variable, and simply call it Blackboard. Plug it into begin play. And that's all we need to do for now. So we're going to get back to a little bit of explanation and how we're going to use it later. Just make sure this is in place. So we also have the variable in here. And then we're going to set up a bit of the graph over here to switch between the states of the turret. So we're going to create a function or a custom event, I'm sorry. And we're going to call this one start combat state. And what we want to do in here, first of all, I'm going to grab a delay of 1 second. And this is not a delay to make everything work. This is simply to give the player a bit of time to react and not be completely annihilated by the turret as soon as he steps into the sight range. So these delays are just for making things a bit more fair in game. You can change the durations of the delays if you like to. It works without delays, but this is simply to give the player a chance to fight back. So we have a delay of 1 second. Then we're going to check if our current state has our shield open. So is aiming, is shield open. Both of those are basically switched on and off at the same time. So we can grab a branch in here. Check if our shield is open. Our shield is only open when we are aiming. So if this is false, we're going to grab the is aiming bool and the shield bool. And over here, plug them into the false pin and set them to true. So these variables drive the animation blueprint. So changing these will make sure that the animation of the turret changes into the aiming animation. Then we want to spawn some fx. So we want to grab our exposed fx from the variables and check if it's already valid or not. So do an is valid check. Plug it in here. If it's not valid, we want to spawn it, obviously. So we're going to drag off and spawn an emitter attached. And we want to spawn it, attach it to our turret mesh. So simply plug in the mesh to the attach to component pin. So the attach point name is going to be our root bone. So simply type root. And then because we scaled down the mesh of the turret, we also want to make some adjustments to the scale and the location. So I'm going to change the location -20 on the z-axis. And for the scale, we want to use 0.44 for all 3 axes. So if you changed the scale on the mesh, you also want to adjust things over here. You need to play around with it a little bit. So for the location type, we want to snap it to the target and keep the world scale that we set here. And that should be pretty much it. So now we can drag in our exposed fx and store it inside of our variable over here. So the only thing we need to do is select our emitter template. So let me check in my example project that I'm actually using the correct one. So we're gonna go into our fx folder and then go to particles and then turret. And in here we want to use the sentry turret exposed fx. So let's look for that one, sentry turret exposed, this one. So if we select it and click the little arrow, it will assign it over here. So that's good to go. So after we started playing the exposed fx, again I'm going to add a delay of 1 second. And again, this is not to make things work. This is just to make the player able to fight back and react. So 1 second delay over here. Because we're using delays, we want to make sure that our current target is still valid. So maybe the player left our sight range and we can't attack him anymore. So we're going to grab our current target. And over here, we're going to double check if it's still valid. So look for an is valid node and plug it in. After that, we want to start aiming, and we have a targeting beam fx that we can play first to make the player know that we're going to fire at him. So we're going to grab the targeting beam fx, and we also want to make sure that it's not already valid. So grab the is valid pin, plug it in here, and add an is valid check for the targeting beam fx. So then if it's not valid, we need to spawn that. So we can grab our spawn emitter attached with the mesh and paste it over here. So in this case, we want to attach it to a different bone, and that's actually called our targeting beam. So if we go to the mesh over here, you can have a look at the skeleton tree, and all the way down over here, we have the targeting beam socket. So this is the one we're going to use, and you can copy the name from here if you like to. So we're going to attach it to our targeting beam. The location is simply going to be 0, and the scale is simply going to be 1. So we can reset those. We want to snap to target, keep world scale, that's fine. And then we can store it inside of our targeting beam fx. So let's hook up a setter over here. So we need to change the actual fx. So again, let me double check in my example project that I'm picking the correct one. So we want to use sentry turret targeting beam idle. So that's this one. Select it over here. Go back to the graph and click the little arrow, and it should be assigned. So that's good to go as well. So again, after aiming, I'm going to add a second delay. So the targeting beam fx will play for 1 second, and the player can start running away. And after that, the turret will start firing. So 1 second delay. And because we use the delay, again, we need to check if our current target is still valid. So we're going to grab the current target is valid node and paste it over here. And if our current target is still valid, we're going to start firing. So we can grab our is firing boolean and plug it in over here and set it to true. So this drives the animation blueprint, and this will start playing the fire animations on the turret. And at this point, we also want to remove our targeting beam fx. So we're going to grab the targeting beam fx with an is valid node. Paste it over here. Let's make sure that we hook up both of these pins. And if this one is valid, we're going to destroy the component. Hook it up to the is valid pin. So this is our combat state event. And this will trigger the turret into starting firing. Now we also want a similar event to trigger our idle state. So we're going to do that one right away. Let me switch my notes quickly. So we're going to create another custom event, and this one is called start idle state. And in here we simply want to reset some stuff. So the first thing we're going to grab is our isAiming boolean and our isShieldOpen boolean, and also our isFiring boolean. So we want to set all three of those to false, and then we also want to grab our burst count and reset this one back to 0, like so. And then all we have left to do is make sure that we remove any fx that might be playing. So we're going to grab our exposed fx and check if this is valid or not. And if it's valid, we're going to destroy the component. So drag off here, destroy component, and hook that one up to the valid pin, and do the same thing for the targeting beam fx. So actually copy these two. Make sure you hook up both of the execution pins over here, and then check our targeting beam fx. And if that's valid, also destroy it. So that's our turret idle state event, and that should be good to go as well. The next thing I want to do is take a look at the fire animation. Let's move our turret card character out of the way for now. And let's go to our animations. So we want to go to turret inhibitors, animations, and in here we have one called recoil. So that's actually what's used for the firing. So let's open this one up. And it's actually a pretty long animation. And if you look at the last part over here, there's not really much happening. So there's a little notch over here at the end, but that's pretty much it. So because I'm going to use burst fire, there will be 3 shots firing pretty rapidly after each other. So what I want to do is make this animation a lot shorter, so it looks a lot more snappy and aggressive. So what I'm going to do is remove all of the frames after frame 15. So if we drag the slider over to frame 15 and then right click, it should say you want to click over here on the actual bar with the numbers. So remove frame 15 to 81, that's one frame too much. I want to remove frame 16 to 81, so I'm going to move it to the right a little bit. And now it says frame 16, so remove those, 16 to 81. So we have a 15 frame animation, and now we're going to add 2 notifies in here. So let's right click on the notify track over here. And then you're going to select add notify and create a new notify. And we can give it a name. So the first one is going to be turret fire. For this one, you want to make sure that you don't put it all the way at frame 0, because then it won't always fire. So make sure you drag it to the right a little bit, put it halfway between frame 0 and 1, and you should be solid. And we're going to add a second notify at the end of the animation, so we also know when it's done playing the animation. So let's right click, add notify, new notify, and this is our turret fire end. Like so. And I'm going to put this one at frame 14. So now we should be good to go. So we can compile the animation or save the animation, no need to compile it. And at this point we can go back to our turret character. Yeah, let's go back to our turret character first. And in here we're going to create 2 events that we are going to call when the notifies fire. So the actual isFiring boolean that we set over here will trigger the fire animations to play. So then our notifies will start firing, and we know when we fired a shot and when a shot is done. So we're going to use that. So we're going to create a custom event. And we actually want to create that somewhere near our combat state event. So let me move our idle state event a little bit out of the way for now. So create a new custom event. And the first one is called turret fire end. So this will execute when the animation for firing is done. And what we want to do in here, first of all, we're going to make sure our current target is still valid. Otherwise, we can simply stop executing over here. So let's grab our current target and look for is valid. Plug it in. If this is valid, we want to increment our burst count because we just fired a shot. So we're going to grab our burst count and we're going to increment it like so. And then we want to compare it. So I'm going to make it fire a 3-round burst. So I'm simply going to drag off here, do equal to, and type 3 in here. So you can change the number if you want to. And hook up a branch. So if we actually fire 3 shots, then we want to set our isFiring boolean to false. So that will make sure that the animation stops playing and also the notifies will stop firing. So set it to false, I'm sorry. And then we're going to grab the burst count and simply reset that one back to 0. So we're ready to fire another burst. After that, we're going to wait for 2 seconds. So again, this is just to give the player time to react and fight back. You can play around with the times we use in the delays. And they are not here to make things work. It's just to make things easier for the player. So a delay of 2 seconds. And when that delay is done, we want to hook it up to our combat state event. And where do we want to hook it up? We have the targeting beam fx is valid. And over here we created the targeting beam. So we want to hook it up right before there, where we check if the current target is still valid. So that's what we're going to do. The delay ends 2 seconds, and then we're going to go back firing. First, we want to know if the current target is still valid. Then we're going to start playing the target beam fx. That will take 1 second, and then we'll start firing again. So make sure you hook it up over here, where we spawn the targeting beam fx, and then in the current target is valid node. Okay, so that's where that one goes. And then we also need an event for the turret fire. So let's create another custom event and call this turret fire. And over here, we're simply going to spawn the FX and the projectiles and things like that. So for now, all we're going to do is spawn the FX because we don't have the projectiles made yet. So we're going to get back to that later. For now, we're simply going to grab our mesh. And we want to spawn an emitter attached. So we can hook it up over here. And let me see. So we want to attach it to our muzzle 1 socket. So again, if we go to our character mesh, scroll all the way down below the targeting beam, we have the muzzle. So we want to use this socket. I can copy and paste the name from here and attach it to the socket. The location is fine. The scale, we can scale it down a little bit. So I'm going to make it 0.8 on all 3 axes. Location type, snap to target, keep world scale. And that's going to be all for now. So we're simply spawning the muzzle flash FX. We do need to assign it, by the way, so let's make sure we do that right away. Go to our FX particles turret folder, and in here you want to grab the sentry turret muzzle 02. Select that one and assign it in the blueprint. So that's good to go. And then we have one thing left to do in here for now, and that's set up event tick. So let's go to an empty spot and let's look for tick. And on event tick, we want to set the current target location and the current target distance. So first of all, we're going to grab a getter for our current target. We're going to right click and convert it to a validated get. So we're only going to do something if we have a valid target. And then we simply want to get the actor location from here. So get actor location. And currently this is at the feet of the player. So we want to raise this up a little bit. You could get the half height of the capsule component, for example. I'm simply going to add a static value. So I'm going to add a vector to it. And raise it up about 40 units, so 40 on the z-axis, and then we can store this inside of our current target location. And then we also want to get the distance to our target and also set it over here, so we can drag off the current target and then look for get distance to. So for this node, we can simply plug into actors and we don't need to use the vector. So that's a bit easier. So we can simply hook up a reference to ourself in here and then store that inside of our current target distance. Nope. There we go. So that's our event tick. Let's compile and save, and that should be good to go as well. Now we do need to make sure that our turret fire and turret fire end events are actually being called when the notifies fire. So for that, we need to go inside of our animation blueprint. So let's go back inside of the animations folder and open our animation blueprint. We can go to the event graph, and in here we can add the notify events. So if you right click, add animation notify event, if you expand it over here, we have the new turret fire notifies that we added. So we can add both of them. And then simply grab the reference to our turret and call the appropriate event. So turret fire, hook it up over here, and turret fire end. And hook that one up over here. So that's good to go as well. Compile and save that. So we're getting close to actually creating and setting up the behavior tree and the Blackboard. So let's go back to our behavior folder, and in here we want to create the Blackboard and the behavior tree. So let's go to artificial intelligence and create the Blackboard first. So this is my Blackboard, GDR turret, and then create the behavior tree as well. So go back to artificial intelligence and then the behavior tree. So this is my BT GDR turret. And so a Blackboard and a behavior tree go hand in hand. There is no use for a Blackboard if you don't have a behavior tree, and a behavior tree will not function if you don't have a Blackboard. And what a Blackboard does is basically allow you to control the variables that are used in the behavior tree, sort of speaking. So if you open up a Blackboard, you can add all kinds of keys in here, and then you can change those keys from the controller or the character, and changing those keys will change how your behavior tree will flow. So that's basically in a nutshell what a Blackboard does, and while we're using it during the series, things will get more clear and I will try to explain it a little bit better. So now that we have these in place, we want to go into our Blackboard and let's set up the keys for the Blackboard that we're going to use. So we're going to add a new key in here, and the first one is an enumeration, and that's our TurretState. So we want to go to the right side over here and expand the key type, and then we can assign the actual enumerator that we want to use. So we want to use our TurretState Enum. And then we're going to add a second key, and that's an object. And this is going to be our current target. Nope. And that's not going to be an actual object, but it's going to be an actor. So again, we want to go to the key type over here and change the base class from object to actor. So that's good to go as well. And these are actually all the things that we're going to add to our Blackboard. So as I mentioned, it's going to be really simple because it's kind of an overkill for this setup, but that's how it's going to be. So we have two new variables added to our Blackboard. The self actor is always here, so that's a reference to the owning actor of the Blackboard. Now, if you open up the behavior tree and expand it over here, you will see it automatically assigned our GDR turret Blackboard, because that's the only one that we have in the project currently. So if you have multiple Blackboards, you want to make sure you assign the correct Blackboard to the correct behavior tree. And if you have that set up, you can also switch easily with these buttons on the top right between your actual Blackboard and the behavior tree. So for now, that's all the setup that we're going to do in here. And first, we're going to go back to our controller and make a few helper functions. And then we're going to get back to setting up the actual behavior tree. So we're going to go back into our turret controller. And first of all, in the event graph, let's set up event begin play, but we're not going to use begin play. We're going to use onPossess. So it doesn't really matter too much because this is an AI controller and AI controllers only exist on the server. So this is related to the multiplayer part that we're going to do later in the series. So there's no instance of an AI controller on any of the clients. So if we use event begin play, we're also on the server, but I'm going to use event possessed because that will give us a reference to our possessed pawn. So let's get rid of begin play and tick. We don't really need those. And let's look for event possess, I'm sorry. And then we have the possessed pawn over here. So that's actually our turret character. So we can cast to our GDR turret. And then we want to store a reference to it. So we're going to promote it to a variable. And that's my BP GDR turret. There we go. And now we also want to make sure that we start executing our behavior tree. So if we drag off here, we can look for run behavior. So run behavior tree, grab this node, and inside here you want to assign the correct behavior tree. So make sure you have this set up as well. So as soon as it spawns in, it will start executing the behavior tree. That's good to go. And now, as I mentioned, we need 2 or 3 functions to help us select and set a target. So the first function that we're going to create is choose target actor. So let's create a new function, choose target actor. And we're going to set this up. So we want to make this pretty simple. I'm going to grab a branch, hook it up here. First of all, I'm going to make sure that my target array actors is not empty. So drag off here is not empty and simply hook that up to our condition. And then I'm simply going to pick a random target to attack. So I'm going to grab the all target actors again, drag off here and do random. So random array item. And we simply want to return a random one. So I'm going to drag off the true pin and then grab a return node. So I can drag this on top of the return node to create the variable. And let's rename this. So this is going to be our selected actor. And if we don't have any actors to choose from, we simply want to return an empty variable. So I'm going to grab a second return node and don't hook anything up in here. So if you want to make this a little bit more advanced, this is the point where you can check the distance to each target, for example, and then select the target that is closest to you. Or you can keep track of how many damage each target did to your turret and then attack the actor that actually did the most damage. So all kinds of checks that you can come up with, and if you want to add those, this is the place to do it, and then return the correct target actor. So that's choose target actor, and then we also want a function to set the target actor. So let's create a second one and call this set target actor. So for this one we need an input, and that's our target actor. So let's add that one and turn it into an actor. So if we set it, we also want to make sure that we assign it to our turret character. So we're going to grab our BP GDR turret and set our current target. So hook it up here and make sure we plug in the actual target. So now the turret knows what target to attack as well. And we also want to update it on our Blackboard so we can have our behavior tree react to that. And how are we going to do that? Well, if we are on the controller, we can simply right click and get our Blackboard. So there's a default variable for this one. We didn't create this one, that was on the character. So this is already in here by default on your controller. So you can select this one. And for Blackboards, you don't actually need to cast to your own Blackboard class. We are setting values on a Blackboard in a different way. So that's what makes it more optimized, and that's why you want to use Blackboard. So you want to drag off the Blackboard, and then you can set a value. And over here you have all types of different keys that you can add to the Blackboard, and you want to select the correct one. So in this case we want to set a value as an object. So we added the object key on the Blackboard, and that was our current target. So the object value is the target actor. We can simply plug that in. And now we can tell the Blackboard what key to update by simply giving the name of that key. So we can drag off the key name and make a literal name. And you just want to make sure that this matches up with the name of that key on your Blackboard. So let's go to the Blackboard. And we want to grab our current target. So let's copy and paste it to prevent any typos. And then paste it in here. So this will assign our target actor to the current target key on the Blackboard. So that's what we want to do in here, and then we can grab a return node in here as well. And that's good to go. And then we want to go back into our remove target actor. And we want to change this up a little bit. So let's disconnect the execution pin over here. And first of all, if we remove an actor from our target array, we want to check if this is also the current target for our turret or not. So we can grab our GDR turret and get the current target. So now we can simply compare that to the target actor that we're going to remove. So let's drag off here and compare it. Like so. So we can add a branch in here. So if this is true, then we're actually removing the current target from the turret. So then we need to update the turret as well. We're going to drag in the turret again and set the target actor. Set the current target. Oh, really? So set the current target. And we want to set it to an empty reference. So there's no target assigned anymore on the actual turret. And we also want to clear the value on our Blackboard. So we can right click and then get our Blackboard again. And in this case, we can simply look for clear value. So drag off the Blackboard, look for clear value, hook that one up. And then all you need to do is specify the key name that you want to clear. So we can grab the current target over here and hook it up. So now that's cleared from the Blackboard as well. And we can hook this back up to the remove from array node. And also make sure you hook up the false pin over here. And for some reason it disconnected the target actor when I plugged it in here. So you want to make sure this one is hooked up as well. So that's the updated remove target actor. So at this point we can return, and that's good to go as well. So these are the helper functions that we need. And now there's only one thing left to do before we're actually going to set up the behavior tree. And that's create an interface. We're going to use this interface to prevent that we have to cast to our character or controller on our behavior tree. So this is just to smooth things out a little bit. So inside of the behavior folder, I'm going to right click and go to blueprints and create a blueprint interface. So let's call this my blueprint interface and then behavior turret. And let's set it up first. So I want to add two functions in here. One is going to be used on the turret controller and the other one is going to be used on the turret character. So to make things a little bit less confusing, I'm going to prefix the first one with controller and then select target. So let's call this turret as well. So controller turret select target to avoid any confusion. And then for the setup of this event, we only want to add one output, and that's a boolean called isTargetSet. So make sure you have the bool set up, and that's the entire function that we're going to use. And then we're going to add a second one, and this is going to be used on the turret character. So I'm going to prefix this with character, and then turret set combat state. Set combat state. And for this one, we actually want one input, and that's also a boolean, and I'm gonna set that to is in combat, or sorry, in combat, or just to combat. How did I actually call it? Combat. Well, that's fine. So if we enable this bool, the turret is going to go into combat, and if we leave it false, the turret is going to go into idle. So compile and save that, and let's get rid of the interface over here. So now we can start setting up our behavior tree. So let's open up the behavior tree. And what we have in here is the actual root. So this is where the execution will start. We can drag off here and then add different types. And the two you're probably going to be using most are the selector and the sequence. So in this case, we want to add a selector. A selector and a sequence are pretty much the opposite of each other. So if we grab in a sequence as well and look at the description, so a selector will execute the children from left to right. That's always the case in a behavior tree. And it will stop executing when one of the children succeeds. And if we look at a sequence, it will stop executing when one of the children fails. So you can use that to determine the flow inside of the behavior tree. For now, I'm not going to go too deep into it. We're just going to use a selector, and things will be clear along the way, especially later in the project when things get a little bit more advanced. So later in the series, actually. So as this node mentions, the nodes are executed from left to right and also from top to bottom. So it will always go from the top to the bottom and then from the left to the right. And there's also little numbers beside the nodes that will tell you the execution order, so you know which nodes are going to be executed next. So we have this selector in place, and from this selector we want to drag off and we want to add another composite, and that's going to be a sequence. So immediately the number 1 will pop up. First this node will execute, then this node, and so it will go to the right. What we want to do over here is drag off again, and we're going to go to a task. So these are all predefined tasks that you can have the behavior tree do. So for example, you can play an animation, play a sound, run an EQS query, all kinds of things. You can also create custom tasks over here with the new task button, and that's what we're going to be doing later as well. For this task, we want to add a little weight. So most of the time, all the way to the right, you want a little weight in here to prevent things from going mad on tick and just to control things a little bit. So I'm going to set this weight to 0.5, and that should be fine for now. So we have a little weight in place. So let's take a look at setting up this sequence. What we want to do is add a condition to this sequence. And if you look at the behavior tree, the condition is called a decorator. So we can go to decorators and then add a Blackboard based condition. So as you can see, there's all kinds of other conditions as well, and we'll get to a few of those during the series. For now, we're simply going to add a Blackboard condition. And what you can do over here is simply check a value of one of the keys on the Blackboard. So what we want to do is select this condition and then change the Blackboard key to our current target. And we want to set the key query to is not set. So if we don't have a current target set on our Blackboard, this will be true. And then it will continue execution over here. So if we don't have a target, we want to select a new target. And for that, we're going to use a task. So we're going to create a new task. It will present you with this window. So a task is going to be a blueprint. So we have a behavior tree task, and then let's call this a turret select target. That's fine. So if we create it, it will automatically open it. And what we can do in here is go to the functions override, and you have the receive execute events. So there's one for AI and there's one for non-AI, for player characters. So in this case, we want to grab the execute AI event, and this will give you a controller reference and a pawn reference. So you have quite a bit to work with in here. But you keep in mind, these are the default classes, so they're not casted to your own class, obviously. So that's what our interface comes into place, and we're going to use the interface in here to make sure that we don't have to cast every time this task is executed. So if we go to the behavior tree, right now we have the wait in here, so it will only fire every half a second, but if you don't have a wait in here, this will fire a lot. So this is on tick actually. So otherwise you're going to cast on tick, and that's something you probably don't want to do. So for the select target, we're going to grab our controller, and we want to call the interface event on our controller that tells it to select a target. So we have controller turret select target, the message interface. And this will actually return a boolean, and that will tell us if we have a new target set or not. Now in a task, you always want to finish with a finish execute. So if you right click and look for finish, so you always need to tell that the task is done. And if you look for finish execute, there's also a boolean in here that you can use to tell if the task was successfully or not. And that relates back to the selector and the sequence nodes inside of the behavior tree. So if a child fails, depending on what node you picked, the sequence will continue or it will stop. So using the finish execute and the success bools on here, you can also determine the flow inside of your behavior tree. So you want to make sure you hook this up to the success pin. So if we don't have a target, the task will fail. And if we have a new target, the task will succeed. So compile and save that and go back to our turret. Our behavior tree, sorry. And we actually, let me see. So we want to call our task over here. So let's drag off here, go to tasks and select our BTT turret select target. So if this works, this will assign a new target, but this will succeed and the sequence will stop executing when one of the children fails. So the sequence will actually continue executing. So what we can do in here is create a second task to set the combat state of the turret. So again, we want to create a task and we want to select the blueprint based task. So that's just an empty new task. And again, let's rename it. So BTT turret set combat state. So it will open it up for us again. And in here, we want the receive execute event, obviously. So we're going to grab receive execute AI. And in this case, we want to check a value on our Blackboard. So we can handle according to that value. So we're going to right click in an empty spot and then we can get the owner's Blackboard. From the Blackboard, we can get a value as an object. So get object. And we want to know if our current target is set or not. So we can make a literal name. And then we're going to check our current target key on the Blackboard. So usually I just copy and paste these names to prevent that you're going to end up with typos and things are not working. So if a name does not exist on the Blackboard, it won't give you an error. Something just won't happen. So it's kind of hard to figure out. So if this current target is valid or not, so let's drag off it and grab an is valid node, hook that one up over here. And then we can simply call the interface event on our character. So we're going to drag off here and look for character turret set combat state, the message event. If the target is valid, we want to enter combat. So we're going to enable the combat bool, and if it's not valid, we're going to disable the combat bool. So hook them up like this, and then we need to hook up our controlled pawn to the actual target of the interface. So hook up your controlled pawn over here to both of these nodes. And then again, we need to finish execution because this is a task. So we're going to drag off here, look for finish execute. And if we actually entered our combat state, we're going to call this a success. And if we went back into the idle state, we're going to call this a failure. So simply grab both of the finish executes and make sure you set the bools correctly. So that should be good to go. And we have the task done as well. So we can go back to our behavior tree, and then in here, we're going to call our new task. So let's drag off here, tasks, and set turret combat state. But for this one, we actually want to add 2 decorators. So we're going to right click, and we're going to make sure that we add a decorator Blackboard. So first of all, we need to make sure that our current target is actually set. So if this didn't work out, then the current target will not be set. So let's make sure current target is set. And we only actually want to update the combat state if our current state is idle. So if we're already in combat state, there's no need to trigger this and actually fire the interface event. So we're going to block it off right away. If we are already in combat, we're not going to do anything. So add a second decorator, Blackboard. Select the second one, and for this one you want to select the TurretState enumeration. So now we can say is equal to or is not equal to or whatever you want to prefer. But in this case we're going to say is equal to idle, and in that case we need to change it to combat. So this is the first path of our behavior tree. And with this in place, there's really not that much left. We want to go back to our selector node and drag off here. And we want to add another task in here, and that's actually set combat state again. And for this one, we also want to add decorators. So again, we're going to add a decorator Blackboard. The first thing we're going to check if our current target is not set. So again, we're going to go to current target and then is not set. And we want to update the state if we are in our combat state and don't have a target anymore. So we're going to right click, go to decorator Blackboard, select this one, and then we're going to select our turret state. And if this is equal to combat, we want to change it back to idle. So if we don't have a target and we are in combat state, we're going to change the state. And that's really the entire behavior tree. So we can kind of walk through this to make it a little bit better to understand maybe. So this was the selector. This will stop when one of the children succeeds the execution. And this is a sequence, and this will stop when one of the children fails. So let's say the first time we come in here, we don't have a target yet. So the current target is not set. So this is actually going to continue execution. It's going to call the task, and the task, let's assume that we can assign a target, so the task will succeed. When the task succeeded, we have our current target. Because the task succeeded, the sequence will continue. So then we have our current target set, and our turret state is still idle. So then we're going to set our combat state. And if we actually switch to the combat state, that means that this will succeed as well, because this has a success on it. So if this succeeded, then the entire node succeeded. So that means that this sequence is a success. And then the selector over here will actually stop executing because one of the children of the selector was a success. But we already updated the combat state, so at this point we're attacking the player. And it will simply start executing over again. And then this will be not true, so the condition will be false because we have a target. This condition will be false because we have a target, so then we're going to simply keep waiting. And we're going to keep waiting until there's no target anymore. So then we have no target set. And depending on if we can select a new target or not, this is going to continue. So if we can select a new target, it will just continue like I just explained. So it will set the new target and then check if we need to update the combat state. If it cannot select a new target, this will fail. So this will return failed, and then this node will fail. So the sequence over here will fail as well, and that will stop executing. The selector will actually continue execution because this one stops when the children succeeds. So then it will go over here, and because we don't have a target and we're probably still in combat state, then it's going to reset the state. If we reset the state back to our idle state, we're actually failing. So that will mean this will continue as well, and then we're going back into waiting. So that's pretty much the entire logic behind this simple behavior tree. Okay, so let's compile and save, or actually just save. And now all we need to do is implement these interface events into the character and the controller, and then we should be good to go. If you liked the video, please consider leaving a like and drop a comment down below if you know what movie inspired me to make this little clip. So first let's set up the controller. Let's go to the turret folder, open up the controller, and in here we want to add the interface. So we're going to go to class settings, and then on the right side we can assign the interface, implemented interfaces, and select our BPI behavior turret. So that will add the interface events for us, and we only want to set up the controller one inside of controller. So let's double click this one. And in here, what we want to do, the first thing we want to do is call our choose target actor function. So let's drag that one in. So this will tell us if we have a target that we can select or not. So we can drag off the selected actor and make sure that it's valid. Plug it in. So if it's not valid, there's actually no target for us to assign. So then we're gonna hook it up to the return node and simply leave the bool false. And if it's actually valid, then we're gonna call our set target actor function. So hook that one up to the isValid pin and make sure you plug in the selected actor. And after that, we want to return true. So we're going to grab a second return node and make sure we set the isTarget setBool to true. So that's the entire interface function for the controller. And now we want to do the character as well. So let's open up our turret. And in here, again, we want to go to the class and add our new interface. So select the BPI behavior turret. And for the interface functions, in this case, we only want to set up the character one. So let's double click it and it will create it. So because we don't have a return value in here, it's actually going to create an event and not a function, but that's fine. What we want to do in here is grab our current turret state. So let's grab it in here and we're going to switch on it. Plug it in over here. So if our current state is idle, we're going to grab a branch, plug it in, and plug in the combat bool. So if this is true, then we want to go into combat, and our current state is idle. So in that case, we want to change it. So we're going to grab a setter for our turret state, and we're going to hook this up to the true pin. We're going to change the state into combat, and then we also want to update our Blackboard. So that's under the component section. We can drag in our Blackboard component. And from here, we can set a value as Enum. So set value as Enum. And in this case, because it doesn't know what enum we are referring to, you can't actually use the enumeration names, but you want to use the bytes. So technically an enum is just numbers going from 0, 1, 2, 3, 4, 5, and the names you see in here are just to make things read easier in the editor, but essentially an enum is just an index. But it's going to be pretty simple. We can just plug it in like this and it will work. So kind of a useless explanation over there, sorry. So plug in the enum and then make sure you get the correct name. So we want to make a literal name and we want to update the turret state on our Blackboard. So let's grab the key name and make sure we plug it in here. And after we did that, obviously we want to start the combat state. So now we can call our event start combat state. And that's good to go. So we want to do the same thing below here. We're going to grab a branch. If our current state is combat and the preferred state is not combat, so if this is false, then we want to change it. So then we're going to grab the setter for our enumeration. In this case, hook it up to the false pin and we want to turn it into the idle state. So then we want to update our Blackboard. So let's copy and paste this. And we can simply hook it up to the enum setter. And then we want to start our idle state. And that's good to go as well. So this should be the final link in the puzzle. And right now the turret should be able to switch between idle and combat. And it will also play the fire animation with the muzzle flash. So there's no actual projectiles and things like that, but we should be able to see if things are working or not. So let's do a little test. So we can actually keep the behavior tree open while we test this, and then we can also see how this executes. So let's keep the behavior tree open in a little side window so we can see if it's working like we intended, and then we can simply hit play. So as you can see, currently the turret has no target and it tries to select one with the branch on the most left. That will fail. The second condition also fails and then it will go into waiting. So that looks good. And by the way, we can also use the gameplay debugger here. So if we enable that one, I'm going to disable the AI category and keep behavior tree open. So on the right side, the list, you can see the Blackboard asset, and you can also see the keys on the Blackboard and their current value. So the current target is none, the self actor is the turret actor that goes automatically, and then the turret state is idle. And on the left side, you can see the actual nodes that it's executing at this moment. So currently it's using the selector and then the wait node. So if we walk into the site perception, you can see we have a current target assigned on the Blackboard and the turret state changes into combat. And again, on the actual behavior tree, it will go back into the waiting state because it doesn't need to change anything to the current state, but it's actually working and it's firing at the player a 3-round burst. And also the targeting beam FX is playing for 1 second right before the turret starts firing, so the player knows he has to run away or dodge. And then if we walk back out of the sight range, you can see the current target on the Blackboard is immediately set to none. The turret state will update to idle and the turret will go back into idle and also to the waiting node. So this seems to be working as intended. That's not bad. So yeah, that's all I got for you guys today. Obviously the series is not done. We're gonna make sure that all of this is actually finished and the turret can actually fire and take damage and all that kind of stuff. But we did the base for our behavior in here as well. So hope you enjoyed today's video. If you did, please consider leaving a like. It helps out the channel tremendously. And then I'll be back soon for more. Talk to you later, guys and girls. Bye bye.